Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing refraction of light, paper 4, and this is classwork for extended candidates. Before we start, please check the specifications you have in your syllabus as a CIE, and you have to write down in the KWL chart what you know and what you want to know, and at the end of the session write down what you learned, and as usual check that what you learned is here in the syllabus. Okay, let's start by question number 1. Question 1, a ray of light from a laser. By the way, you know that laser, it's an abbreviation for light amplification by stimulated emission of radiation. Please check also RBL at the end of our videos. You can find general knowledge, some related topics, and important information. Okay. A ray of light from laser. Laser is monochromatic light. Okay, so it will pass from air into a clear semicircular plastic block, and the ray will continue in the same direction. Here, as we said, it will continue in the same direction. This radius is perpendicular to the tangent. If you draw a tangent at this point, so this is normal line. You consider it as a normal line. So you can consider the incident ray is along the normal. So in this case, angle of incidence is equal to 0. Angle of refraction also will be equal to 0. Okay, the refractive index is given, and when it meets the flat surface of the semicircular plastic block, it will behave in a certain way. It will continue into air. So it didn't mention that it will be totally internal reflected. Just to calculate the angle between the normal and the new path taken by the light. Okay, here you have 3 marks. You should calculate and show your working. You have to show your working. First step, it's mentioned already that the ray will continue into air. So no need to check the critical angle. But if you have a prism, later on in other questions, you have to check the relation between the critical angle and the angle of incidence. Okay, so here by applying Snell's law, you know that N of plastic sine I, here angle of incidence in plastic, not in air, is equal to N air sine angle of refraction in air. So when you substitute, N for the plastic is 1.5 sine 40 is equal to 1 times sine R. Rearrange, so sine R is equal to 1.5 times 0.642. This value shouldn't be rounded. You have to round only final answers. Okay, guys? So sine R is equal to 0.9 0.64. Also, this value shouldn't be rounded. R is equal to shift sign your answer, which is 0.964. So angle R is equal to 74.6 degrees. Okay? Okay, so this is the first part of our question. You have to show your working. The second part, the frequency of light produced by this laser is given in hertz, and check it's hertz, not kilohertz, not megahertz. And the wavelength in the plastic is given in meters. The speed of light in this plastic. Calculate the speed of light in this plastic. You know that wave equation, V equals lambda times F. Okay, guys, if you draw this triangle, that V related to lambda and F, this is not considered as show your working. You have to write down equations, okay? Substitute, the wavelength is 5.3 times 10 to the power of -7. It should be in meters. And the frequency 3.8 times 10 to the power of 14 hertz. The answer is 2 times 10 to the power of 8 meter per second. Okay? The speed of light in air, it has 2 marks. You know already the value of speed of light in air, which is 3 times 10 to the power of 8 meter per second. Okay? But here is asking you to calculate, not to state. Calculate, not to state. Not to give numerical value. No, you have to calculate. So you have to show your working. Don't just write the value you know for the speed of light in air. So show your working. You have to apply the ratio between the speed of light in air and speed of light in medium. Rearrange. So you have C here is unknown. So rearrange. C is equal to N times V. N, it was given in the first part, 1.5, and V, you have it from your answer here. So you have to write here the answer. And don't forget to write the correct unit. Units should be consistent. Okay? So the answer is 3 times 10 to the power of 8 meter per second. So although you should know this value as extended candidates, but you have to calculate and show your working. Okay, guys? Explain why the ray doesn't change direction as it enters the plastic. I already explained it in the first part. We will write the answer here. The incident ray, the incident light ray is perpendicular along the normal. Okay? Angle of incidence is equal to 0. Also, the refracted ray is perpendicular along the normal, and the refracted angle of refraction is also equal to 0. Angle of refraction is equal to 0.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.